All right, I'm going to try this once again. We're going to try and create this video. This is the part 2 video for two-way analysis of variance, or factorial analysis of variance. I'm still coughing, so bear with me there. The two-way of analysis of variance adds an awesome little twist to a regular analysis of variance, and that twist is an interaction term. And you can test the interaction between two independent variables. So you set this up with two independent variables, or two factors as we sometimes call them, predicting one dependent variable. And you can evaluate the influence of those two independent variables separately and together. So you have three variables, which means you usually need 3 columns of data in SPSS or R or any other software program that you're using. And those data are set up in such a way that it's kind of the standard paired data type situation, except that 2 of those variables are categorical variables, and all they will do is list which category each participant is involved in. So even though it's paired data, this sets up between subjects, so like an independent samples type situation, not a paired samples type situation, even though the way the data are entered looks kind of like a paired data situation in some ways. It's long format data. But each participant gives 3 pieces of data, like their value on the dependent variable, which category they're in on independent variable 1, and which category or group they're in on independent variable number 2. This is called a fully crossed design, where each person has a membership in both category 1 and category 2, and all the memberships have people in them. All the categories have, well, it doesn't have to be people, have participants or cases in them. So the things that we want to know that factorial analysis of variance can tell us is what is the effect of variable 1 on the dependent variable. We say effect, and effect means the amount to which the means of the different groups in that independent variable are different in the dependent variable. Or another way to say that is the association between independent variable 1 and dependent variable. And then we can find out that same thing for the independent variable number 2. Now, the interesting part is we can also look at the effect of the interaction between independent variable 1 and independent variable 2 on the dependent variable. That interaction is the thing that makes factorial analysis of variance awesome. So the first effect there, the first main effect of factor number 1, there will be an F ratio for that specifically and a p-value. And that's exactly as if it was a one-way ANOVA with only that factor. Factor 2 will have that too, and that's exactly as if it was a one-way ANOVA for the second factor, but both of those things will be listed in the ANOVA table. And then there'll be a third thing listed in the ANOVA table, which is the effect of the interaction between factor 1 and factor 2. So the main effect, to go over some terms here, is the association or the effect or the mean differences among the groups in one independent variable, and the differences are on the dependent variable. So it's the association between a categorical independent variable and a dependent variable. And the independent variables are sometimes called factors, and a common way to talk about them is factor A and factor B, until we have a situation where you have specific names, and then you use the specific names of those variables. And each time you look at the main effects, you're looking at the effect of one independent variable at the mean differences in one independent variable as if the other one didn't exist. It's just like doing individual one-way analyses of variance. The interaction effect is a little bit different. That's the new part. That's the different part. It's a little bit kind of like a chi-square test of independence, and it definitely is an independence-dependence type situation. So one two-way ANOVA is better than 2 one-way ANOVAs, because in the two-way or factorial ANOVA, you find out about the interaction effect. Now, the way we kind of conceptualize the data, this helps to understand what's going on. We have multiple groups, and we need 2 or more levels in factor A and 2 or more levels in factor B. 2 is okay in each one, because you can't do t-tests with 2 factors anyway. You need ANOVA. So anything more than just 1 level. And we could look at our data like this, just something that shows us the means or the medians or something in each cell. So you can see how this design is crossed here. Oops. These 3 levels of this factor are crossed with these 3 levels of this factor. They're literally physically, visually crossed here. And conceptually, research-wise, they're crossed because everybody is a member of both a subject group and also a group that saw a particular age of sex offender. So this is from the punishment attitudes questionnaire, as you might have guessed by now. Excuse me. And this punishment attitudes questionnaire was a survey that had people looking at vignettes or little stories that involved sex offenders, whether a teenage sex offender or an adult sex offender. And the survey was sent to 3 separate groups of people: American Psychological Association members, Association for the Treatment of Sex Abusers members, so people who worked with sex offenders, and then just standard undergraduate students at Ohio State University. The Ohio State University. So you can see the design here. And so we could look at this and we could figure out some patterns. Well, there, that middle is like this for teenagers, for APA, and then for ATSA, they assigned a little bit more accountability, because that's our dependent variable here, sorry. The amount of accountability that each person thought the offender had for his actions. So ATSA people thought teenage offenders had a little bit more accountability, and then undergrad students thought that teenage offenders had the most accountability. So you can look at those patterns in the different groups in various ways. It's a little more common to look at it like this, however. You have on the dependent, or on the y-axis, you have your dependent variable. This is the accountability that each person attributed to the offender. And then the 9 separate groups of people are plotted as 9 separate dots. When we put lines between the dots to connect them, the lines don't mean anything. They just help us visually organize the graph and see what goes with what. So we have the levels of one of our variable on the x-axis. And the levels of our other variable are represented by separate lines. So we can really see patterns here. We can see that things are mostly parallel here, but not exactly, and that in general there's an upward trend from left to right, that as sex offenders get older, people are more likely to assign them or say that they had accountability for their actions. So the main effects in this particular case are, first of all, the main effect of factor A, the main effect of offender age or developmental level. That main effect means the amount to which accountability ratings vary just by offender age. Now, of course, just as a quick reminder, of course, accountability ratings vary by everything in our sample. That's not what we're interested in. We're always interested in the population. So in the sample, there's a difference. So the question is that variability great enough that we also think that it's happening in the population? The effect of factor B is the subject group. The effect of the subject group is the extent to which the means of the 3 different subject groups vary. The variable of the mean here is the accountability rating, so the dependent variable. So accountability ratings vary by the particular subject group. Again, we're trying to guess about the population. And the interaction effect, the description of this is similar to the chi-square independence test. Does the effective offender age on accountability ratings vary by subject group? Now remember, effect of offender age means differences in accountability means differences in average accountability at different offender ages. So there will be differences in accountability ratings for the 3 different offender ages. Do those mean differences? Does that pattern of differences, does that change as you go from the APA group to the ATSA group to the undergrad group? Another way to say that is, does the effect of offender age on accountability ratings depend on which subject group you're looking at? So there's a lot of different ways to describe this that are all equivalent and all equal. I'm trying to list lots of them. So if you think about them all together, hopefully you'll start to kind of get an intuitive sense of what's going on here, which is hard. Now, of course, there will be an interaction effect. There will be some it depends going on in the sample. And again, that's not what we're concerned with. We're concerned with the population. Is this happening in the population? Is it happening enough in the sample that we trust that it's also happening in the population? So that's, as always, that's our concern. This leads us to quiz question number 6. How many hypotheses are tested in a two-way ANOVA? That's not including any post hoc tests. So before you get to the post hoc tests, which are optional, how many hypotheses get tested? So moving on. Here's what the results look like in a two-way ANOVA. There's always going to be some kind of a line that shows you, that's labeled with your first factor, your first independent variable, and it's going to have the standard thing: sum of squares, mean, degrees of freedom, mean square, F. Now, unless you're interested in the details of how the analysis went down, which often you won't be. The things you really want to look at are the name of the factor to make sure you know what you're looking at, and then just skipping over to the p-value. Sometimes there's no p-value, there's just some asterisks after the f value. Now this is a huge F, so yeah, the offender age is very significant. It's highly statistically significant, which means there was a pretty big difference between the mean accountability ratings at the different offender ages. Now then you see the main effect of the other factor, subject group. Now it's a smaller effect, but an F of 44 is still pretty freaking huge. So there were the subject groups in general gave different ratings of accountability, like irrespective of offender age. And then we have the offender age by subject group. Now we usually write that with an X. We name one variable, X, name the other variable. And that's the interaction of offender age with subject group on how it affects the dependent variable. Everything here is how it affects accountability ratings. Now that F is small, but we have such a huge sample size that fairly weak little interaction there, we can tell it's kind of weak because the F is really not very big. That weak little interaction is still statistically significant. So there is an interaction, just not a really, really strong one. And then we always have this line that's, I put all the names here, but it'll probably only have one in any software program you use. It'll say within group variance or within, or it'll say error, or it'll say residuals. And actually there are more options because there's a lot of discussion about this. But for this class, it'll be one of those. The textbook likes residuals, so we can go with that. So let's talk about how we interpret this offender developmental level or age effect. So the main effect of age, how do we see that in the graphs and how do we understand it? So let's look back at this graph again. We see the means as they are. So the effect of age is just irrespective of what group you're in, do accountability ratings vary according to the different ages of the offender? So are there different mean accountability ratings for children and for teenage offenders and for adult offenders? We can look at the graph and see that yes, there certainly appear to be. So if we imagine lumping together, like imagine we didn't even ask you what participant group you were a part of. We just lumped all the surveys together. Then all of the surveys at the child level, their mean would be around here somewhere, the mean rating for children. So we just kind of lumped together. And then here we lump together all the teens, and that mean is there. And we lump together all the ratings for adult offenders, and the ratings are there. And we can just see that there's a pretty big difference between accountability for adults and children, and pretty substantial differences for adults and teens and children. So the effect of offender age is the same result you would get if you did a regular one-way ANOVA with just offender age predicting accountability ratings. And so the fact that it's statistically significant, the p is less than 0.001, suggests that there is variability in accountability ratings at different offender ages. So it's ignoring the group completely. They're ignoring group membership completely. So let's look at group membership though. That's our second factor. Let's look at this graph again, and let's parse it a little bit differently. Now there are different things we could do here. We could redo the graph and put group on the axis and ages on the lines. And that would be pretty neat, but we can also just do this. We can just kind of visually lump things together. So the effective subject group says, what was the mean rating of the different subject groups compared to each other? So those are all the undergraduate ratings. Maybe here, that horizontal little reddish purplish bar. Now here's the ATSA group. If we just take everything straight horizontally and lump those together, then the mean rating would be about there. And then the APA group, their mean rating on average would be about there. So we have some differences. And there's definitely a bigger difference between undergraduate and everything else than there is between APA and ATSA. But the significant F test just tells us the p-value of less than 0.001 for F tells us that there is some variability somewhere among those means. Now, it looks like it's probably mostly due to the difference between the undergraduate group with the other two groups. But there could be a significant difference between APA and ATSA. We wouldn't know unless we did some follow-up tests to check that. So that's the main effect of that factor B there. Now looking at the interaction term, it's a little harder to visualize what's going on here, so I'm not going to try. I'm just going to say that the lines are not parallel. If the lines are not parallel, then there's an interaction of some sort. If they're enough not parallel, then we would find that p is less than 0.05 or 0.01 for that interaction. We would say there's a statistically significant interaction. Now, if we had a slightly smaller sample size, not like 600 or whatever this is, then we might not find a significant interaction because these lines are not a lot different from each other. They're mostly parallel, but we have a big sample size. So those slight deviations from perfect parallelness, parallelity, parallelism, parallelation, deviations from being parallel are enough with this large sample size for us to say that this small interaction effect is probably also present in the population. So the interpretation of this is that the effect of offender age on accountability ratings. So the differences in accountability ratings that exist at different offender ages, those differences are different for different subject groups. You could rephrase this, flipping the groups back, or flipping the two independent variables around, reversing their position, and it's also a reasonable interpretation. The effective subject group, the pattern of mean differences in accountability for different subject groups, depends on offender age. In other words, the pattern of differences in means between the subject groups changes for the offender age. So here we can see that the pattern is APA, and then right above it ATSA, and then, I don't know, 2 or 3 times higher than that, undergrads. And here is APA and ATSA, and then these two aren't as close together here, and they aren't as far away from this one. So the pattern has changed. Not a lot. It's a small change. It's a slight change. And then here, this pattern here looks kind of similar to this, but this one in the middle is different. So the pattern of how the means are related to each other here is different across the different offender ages. So that's what the interaction is. It's a very weak interaction, but there it is. So let's look at another example where the interaction effect is pretty obvious. The effects of educational method and instructor education on students' grades in a math course. Made up data. I got it from a textbook, but it's fake anyway, I think. So factor A is the educational method. We have traditional lectures, multimedia presentations, group learning, or self-directed learning. This is a fully between subjects design, so we need like 4 different groups of participants. But then we have factor B. So group 1 has to be divided up into 2 groups. We need traditional lecture by bachelor's degree, traditional lecture by master's degree. Factor A level 2 multimedia presentation group, that has to be further subdivided into bachelor's degree and master's degree groups, etc. So we're going to have 8 separate groups of participants. The dependent variable for everybody is students' grades. Now we sometimes diagram this just as a 2-way table, and it's really similar to a chi-square table. You name the variable here, you name the levels of the variable, and then you put the number of participants in each group. And here you name the variable, you name its levels, and you cross those. Now, you wouldn't do a chi-square on this most of the time, unless you were doing a survey and you were testing to see whether the frequencies were not equal or were dependent on each other or something, of who responded to the survey and who didn't. But with an experiment, you can usually kind of control how many people go into each group. Now we see that the ends are not exactly the same in each group, and that's probably okay. Although there are advantages to having completely equal n. Question number 7. How many participants total took part in this study? All right, so moving on. Another way to see the setup of an analysis of variance is, instead of the n's in there, we could just write in the name of the dependent variable to remind us that there's one dependent variable mean for each grade. And after the results are done, sometimes we can just put the mean and standard deviation. I had a problem with x bars today, so it says m instead of x bar. So we can put the sample mean for each cell in the cell. So here's what the results for this particular study might look like. And all 3 effects are significant: main effect of A, main effect of B, main effect of the interaction. One thing you should notice is that it's pretty hard to figure out what the graph would look like just from this. For instance, there's an effective educational method, but that tells us nothing about whether lecture was more effective than group, or group more than lecture, or anything like that. And much less being able to figure out what the interaction looks like. So we really need to look at the means. So we can look at the means in a table, and that helps some people. I'm not really great at reading tables. I'm better at reading graphs. So here's a graph. We've got a line for the bachelor's instructors classes and a line for the master's instructors classes. So all 8 classes are represented here. These lines are not parallel to each other. So as long as there's a decent sample size, we would see that p is less than 0.05 for the interaction effect. So we can see some reversals, for instance. So for lecture, master's classes did better. Classes that had a master's level teacher did better. But for group testing, classes with a bachelor's level teacher did better, or for group class formats. And then there wasn't as much of a difference for multimedia or self-directed learning, although the smaller difference might matter as well. We could rearrange the graph by putting factor B on the x-axis and factor A has separate lines. And that might help us see things a little bit more clearly as well. Now we can compare the different, more directly, the different methods to each other. So here, it's easier now to compare the different, well, I think it's easier to compare the different levels of teaching, or levels of education of the teachers to each other. But here it's a little easier to directly compare the teaching methods to each other. And we can see that self-directed is not doing great. But we can see that here too, because the self-directed means are both pretty low. I mean, all the data is in both graphs. But here's a question, opinion. Which graph do you prefer and why? Please answer that question. And that's the end of that lecture, hopefully. Let's go back, and with any luck, this actually recorded this time.